Okay, so I think we're ready to get things started. So welcome everyone, and thanks for attending today's webinar on Managed SD-WAN, your gateway to better customer experiences with TGO and NetFortris. So my name is Katie Sherrill, and I'm the marketing manager at TGO. Just before we get started, a couple items to note. If you have any questions throughout the webinar, you can go ahead and submit them in the Q&A box at the bottom, and we will be monitoring those questions and opening up to a Q&A session at the very end of the webinar. We will be recording this session, so we'll make sure to provide you the webinar recording following the presentation. And finally, we also will be conducting a live giveaway for the winner of the Netflix gift card. So we'll also conduct that towards the end of the presentation. So with that, I'll introduce our speakers for today. So from the TGO side, we have presenting David Whale, the product manager for connectivity solutions at TGO, as well as David Pluis, the solutions architect at TGO. And then from the NetFortris side, we have presenting Stephen Horgan, Director of Product Management at NetFortris, and Derek Donian, Director of Sales Engineering at NetFortris. So TGO and NetFortris have partnered together to deliver best-of-class managed SD-WAN solutions to help customers design and build their advanced networking infrastructure. So with that, I'm going to pass things off to David Whale to take us through today's agenda.
Okay, thanks, Katie. And thank you everyone for taking time out of your busy day to be with us. We've broken today's webinar into three parts. I'm going to start out by talking about SD-WAN in general. What is SD-WAN? What are the business drivers for SD-WAN and the benefits of SD-WAN? And then I'm going to hand it over to Steve Horgan and Derek Doney of NetFortris. They'll be taking you through some of NetFortris's experiences with SD-WAN customer deployments. And then we'll switch gears. We'll have David Pluis from our sales engineering team take you through a demonstration of some of the capabilities of the VeloCloud platform. So the first part is, what is SD-WAN? And sometimes I find it very difficult to succinctly define what an SD-WAN is. Most conversations I end up having with people generally end up talking about features and how SD-WAN works. And part of the problem is there are so many definitions for SD-WAN. It seems like every solution that can build an encrypted tunnel across the internet today is now called SD-WAN. So I often find it easier to talk about the important characteristics of SD-WANs and how SD-WAN should work. So I think when you say SD-WAN, most people think of this, a simple point-to-point encrypted tunnel across the internet. And by all means, all SD-WANs can do this. And ideally, if you were going to actually set up a point-to-point connections across the internet, you would actually have two internet connections, or you should have two internet connections with different service providers. This would provide you the best resiliency and reliability. But SD-WAN shouldn't be limited to just using the internet. SD-WAN should be able to support hybrid type networks, public and private networks, MPLS, Ethernet, maybe point-to-point connections. Supporting private connectivity is an important feature for businesses. When you consider that most businesses will be moving from a legacy network to an SD-WAN, there's going to be a transition period. That could be a couple of months or much longer. And so during that time, the SD-WAN should be able to support traffic across the private connections during that transition. Also, there's going to be many business critical applications. The business will want to continue to run across private connections even when they have SD-WAN. So in that case, the SD-WAN needs to be able to support these types of private connections. So this drives to my first important point or characteristic when I'm talking about SD-WANs. So SD-WANs themselves are overlay networks. They're point-to-point encrypted tunnels built over top of physical networks, whether those are internet connectivity, public networks, or private connections. And point number one on it, SD-WAN should leverage multiple physical network conditions, ideally with different service providers. This is how SD-WANs can achieve superior network reliability and resiliency. Point number two, SD-WAN should automatically steer network traffic and correct for network errors, things like packet loss and jitter, based on the real-time network, physical network conditions, and traffic types and application types that are flowing over the network. This is how SD-WANs can substantially improve network and application performance. And then the third point, SD-WAN should be able to aggregate, divide, and utilize bandwidth according to business needs. So SD-WANs need to be able to leverage all of the available bandwidth. We're not just talking about failovers in the event of a service incident or an outage. By managing all available bandwidth, SD-WANs can optimize bandwidth usage, often reduce the amount of network bandwidth that's required, and can reduce network costs. The second important characteristic that all SD-WANs should have is a cloud-based management system. Now, this is generally referred to as the orchestrator. The orchestrator manages customer configurations and network and traffic prioritization policies. It should feature zero-touch configuration. So the orchestrator automatically pushes out configurations to SD-WAN edges, either during deployment or when you're making changes to your network. And then the third point, SD-WANs fully separate out the data plane from the control plane. So the cloud-based management system should manage the real-time state of the network and automatically update the edge devices according to real-time network conditions, things like changes in network topology. And then the third point is being able to support cloud-based applications or support cloud applications in general. It's a primary reason that SD-WAN was developed was to manage and optimize connections to cloud service providers, private clouds, and to cloud-based applications. So why are businesses moving to SD-WANs? That's pretty simple to understand. Business applications and business operations are changing. When you think about applications, more and more business applications are moving to the cloud. Businesses are moving workloads to cloud service providers like AWS, Azure, Google, and many businesses are now using cloud-based applications like Salesforce, or even things that were traditionally desktop applications like Office 365. I always like to point to the bandwidth hogs. Bandwidth intense cloud-based applications, things like streaming and file sharing services, those have a dramatic effect on the way that legacy networks perform. And then the third type of application I always like to point to are UCaaS type services. So many businesses have accelerated their movement towards things such as Teams, Slack, and other type UCaaS services. It's very prevalent, and it's something that needs to be dealt with again, or that legacy networks have a problem dealing with. But operationally, businesses are changing as well. Operationally, the cloud is being used more and more to support business connectivity. So I like to focus on three separate things, which I think are very important when we talk about that, the operationally how businesses are running their networks today. Even before COVID, businesses were dealing with increasing numbers of mobile users, sales teams, contractors, people working from home. Additionally, there's more and more remote devices and remote processes that are being run out there. Think things like Internet of Things, where you use wireless and internet connectivity to connect these devices to their supporting gateways and to the applications that are being run out of either data centers, or more commonly, they're being run out of the cloud, such as a place like Azure or what have you. The third part that I always like to talk about is international connectivity. So at one time, the need for international network connections was pretty well the domain of large multinational firms. They used expensive private connections. They were hard to deploy and hard to scale. But business has really changed, and even small companies today are partnering and contracting with companies in other countries. And whether you're big or small, most of that connectivity is moving towards the internet. They're not paying big bucks for having those private connections across the world. They're using the internet to connect to their international offices, whether their own offices or partners or contractors. So what it means is business networks are becoming more cloud-centric, but the legacy networks that they're built around, they're all point-to-point and point-to-multipoint type private networks. They're not able to support that type of infrastructure. It means you end up with a lot of hardware that you have to deploy, manage, and maintain. You're probably using multiple management systems to maintain them. If they are being managed by that, in some cases they're still being manually managed. All in all, it means that these types of networks, the legacy network infrastructure, it's too complex. It's very difficult to deploy. It's difficult to manage, and it's difficult to scale. And it's too expensive. When you consider all of the hardware that's out there, you have to pay for managing all the hardware and all the maintenance with it. Too much private connectivity being used, and the amount of network and security management costs that have to support it. And this is really where SD-WANs come into their own. So SD-WANs are there to simplify business network infrastructure and management. So this SD-WAN diagram may look a bit overly simplified, but it is actually a pretty common deployment for many businesses. When you look at the four main parts of it, it simplifies connectivity. We have high availability connections built from readily available internet services. It reduces the amount of hardware that has to be put out there. We can aggregate all the connections into one SD-WAN edge on it. And I know I didn't draw a private connection onto this just for clarity and make the clean the diagram up a bit. But if there were private connections onto it, those could also be connected into the same SD-WAN edges in this network. So you reduce the amount of hardware you have to deploy. It has a cloud-based focus. It's not just about managing point-to-point, site-to-site traffic across the network. It's able to manage internet-bound and internet-source traffic. And lastly, it's easy to manage. You have one centralized management system that manages and controls the entire network. So when you talk about the benefits of SD-WAN, I like to break it into four discrete sections. First of all, I'll talk about is performance and reliability. 4 nines of availability or better in some cases, and that's by just leveraging multiple diverse connections into your network. You can significantly improve network performance. So dynamic traffic steering means that the application traffic can be directed according to network conditions in real time. You can optimize your network performance. And the SD-WANs are able to manage degraded service conditions. They have built-in error correction mechanisms that can correct for network errors, things like jitter and packet loss. Secondly, management agility. Zero-touch configuration of the orchestrator and internet connectivity makes network management really flexible and very easy. It's easy to quickly deploy new sites. It makes it significantly faster to implement network changes. You just make your change to the orchestrator, and then the orchestrator pushes those changes out to all the boxes across the network. Highly scalable networks, whether you're deploying a large network or a small network, sites are domestic or international sites, it's very easy to deploy. It's pretty well the same. And if you have small networks, it's easy to grow to large networks using SD-WAN. And then the fourth point is something that's often overlooked, but I think is pretty important. It's easy to support short-term deployments, things like pop-up shops and construction sites and what have you. If you can, you can literally set up these sites within a few days or tear them down in a few days as needed. As long as you can get the connectivity there, you can actually set up a site really quickly. Of course, cloud-based services, extending SD-WAN connectivity management and control to cloud-based service providers, private clouds, and cloud-based applications. That's a huge benefit of SD-WANs. And then the last one, cost efficiency. So somehow SD-WAN discussions always generally converge to cost savings discussions. So I generally save one slide to talk about this. So I've done a lot of modeling on the SD-WAN type solutions. And if you compare an SD-WAN solution to a similar sized legacy network, I figured that the average business could save somewhere between 30 to 50% on their WAN implementation. There's obviously variability in that. But primarily all of that savings comes from savings on private connectivity. So it's pretty obvious there's a lot of mundane business traffic flowing across private networks. And companies that have good reason for, in many cases, for actually maintaining some private connectivity with their SD-WANs. But the reality is you can reduce the amount of expensive private bandwidth that you're running today. You can reserve it just for those applications that are critical to your business and run site to site. You can reroute any non-priority site-to-site traffic across public networks, and you can reduce the amount of internet-bound or internet-sourced traffic that's being backhauled across your private network, which is still a big problem for a lot of business networks today. Secondly, bandwidth optimization. By being able to aggregate, divide, and utilize bandwidth in real time, SD-WANs use bandwidth more efficiently. They just require less bandwidth to move the same amount of traffic. And then the last point, and I think it's probably the greatest cost efficiency, and it's not something that I can account for when I do my modeling because businesses are so different. It's difficult to estimate the IT cost savings. But the SD-WAN management capabilities can significantly reduce the amount of time that valuable IT resources spend working on WAN issues. So things like reducing incident management, managing network outages and degraded service conditions. It means your IT staff can manage, because the network's going to handle the outage and the site isn't going to go down if one connection goes down. It means that your IT staff will have time to respond and manage the incident in a reasonable manner, and meaning a lot of reduced escalations and fire drills, which is very common today when a site goes down or a connection goes down. Reducing planning on new sites, zero-touch configuration and internet connection makes setting up new sites relatively easy, at least on the WAN portion. Gives you more time for your IT staff to actually work on setting up the IT infrastructure in the new site or the applications that go along with it. Again, reduce change management effort. Any changes that are made to the network are very easy to implement and deploy. And then the last part, again, something that I find that's very often understated when we talk about the SD-WANs, it reduces the amount of IT effort for rolling out new applications or changes. So SD-WAN platforms have existing application and traffic profiles, meaning that the SD-WANs actually have a default configuration that already has a good idea of how to handle application or traffic types across the network. What's more, SD-WAN platforms update these profiles as the applications get updated or as they get new features. So it means your IT staff has to spend a lot less time configuring the network and supporting new applications as they get rolled out. The last thing I wanted to talk about today briefly was TeraGo's own managed SD-WAN platform in general terms. So full disclosure, TeraGo's managed SD-WAN is deployed on a VeloCloud platform. VeloCloud is leader in the SD-WAN space. It has more than 3,500 globally deployed customers. Now, there are a number of reasons why we went ahead and chose it, but the two main important points I think when we look at this are performance and capability around cloud services. In terms of performance, 3,500 customers and thousands of cloud applications, the breadth of these deployments is very important to SD-WAN platforms. It means the VeloCloud platform is continuously learning from real network traffic, and the SD-WAN application profiles are continuously being developed and fine-tuned. That scale benefits all business networks that are deployed on VeloCloud. And of course, it also benefits companies like TeraGo that actually have to manage those networks. So it means better performance and overall better reliability. The second point is that TeraGo is not just a connectivity provider, we also are a provider of cloud and managed services. So when we are actually going through the selection process for SD-WAN platforms, our TeraGo Cloud Services team judged, as part of the criteria, judge VeloCloud as the best in class as being able to support cloud services and cloud applications. The second part of our disclosure, so TeraGo, when we released our SD-WAN product, we partnered with NetFortris. So NetFortris is a global communications provider. They support over 11,000 businesses all across the world. TeraGo realized that SD-WAN was really just getting going in Canada. Relatively speaking, there are few SD-WAN deployments. So it made sense for TeraGo to partner with a company who already has extensive experience delivering VeloCloud solutions. And I'll let Steve and Derek talk about their VeloCloud experience in a minute, but NetFortris has some 70 SD-WAN customers and has deployed over 1,000 SD-WAN sites. And secondly, very important for us is their international footprint. So NetFortris has the capability to support international deployments, and that's particularly important for Canadian businesses because many Canadian businesses have US or international sites that need to be reached as part of their WAN. So that's the end of my session. I'd now like to introduce you to Steve Horgan and Derek Donian of NetFortris. They're going to take you through some of their SD-WAN experiences and deployments. Thanks for your time, everyone. Steve, I'll hand it off to you.
All right, thank you, David. Hello, everyone. Good afternoon. This is Stephen Horgan. I'm Director of Product for NetFortris, and I just wanted to spend a couple of minutes just talking to you about why we chose to go with VeloCloud. We've been a proud VeloCloud partner for some time now, and so, just speaking on that for a little bit, I wanted to kind of go through that and what made us choose in that direction. SD-WAN is a technology that we're seeing a lot of quick adoption for, and that's not just on the customer and user side, but we're also seeing a lot of service providers, vendors coming out with their own SD-WAN technology and SD-WAN products. So through an evaluation period, there was quite a bit out there for us to look at, to choose from, and to evaluate. And so what we found really early on, we discovered quickly that VeloCloud provided really the best combination of features and functionality that we were looking for, combined with the ease of implementation, the support, and the management to support the platform. What we see a lot in the industry, in the market today, is technologies that are either very feature rich, but requires a senior level engineer just to be able to construct a solution. And on the flip side of things, we see a lot of service providers that have a lot of pretty interfaces, really easy to get into, but has a lot of gaps in terms of what the value that they're able to provide. So we found that VeloCloud was able to really provide that sort of combination of an interface that's simple and easy for us to use, as well as being incredibly feature rich and able to provide a roadmap that we were very interested in and very comfortable with. And when we talk about ease of implementation and support, this is from a service provider's perspective. So, what does that really mean for an end user who's taking this on? Well, it means a lot. Even if an end user may not have any visibility to the orchestrator or to the platform that's running their solution, from a service provider perspective, this is it's critical for us to be able to scale a solution from North America and internationally. When we're relying on level 1, 2, and up support engineers to be able to implement a solution, take support calls, be able to evaluate new features and functionality, it's going to need to be a solution that's going to be intuitive for us to use and make sense. And so that was something that was really critical for us when looking at the solution, because those level 1 engineers are going to have to take those calls. They're going to have to troubleshoot issues. They're going to have to, tweak a system for customers' preferences, and they're going to need to know how to do that and not have to take it to a senior level engineer to be able to figure out or to understand a problem or to understand a request. So that's so critical for us to be able to scale a solution outside of our bubble and into other areas. And as support personnel come and go and we expand our teams, being able to onboard new folks and new people into the product itself just makes it much more easier. And that not just goes from a support perspective, but we're also talking about expansion from a head-end perspective. Being able to expand our head-end deployments, we've been constantly impressed by the technology that VeloCloud provides to be able to expand our gateways, what we call our gateways, in different markets. So easy, so simple. Really could be as quick as it takes for us to get the data center space. We can get a head-end instance in a matter of hours spun up and ready to go, ready to support a new region. So from an expansion standpoint, ease of use and implementation, ease of expansion, these are all things that have really allowed us to become successful with the product. We couldn't do it without the VeloCloud solution. On the flip side of that, we also have things such as purpose-built hardware and proprietary technology that David mentioned, and that you're going to see another demo on shortly here. The packet level failover that VeloCloud provides is really unique in the market, and so what we are really interested in with their sort of failover technology, it's one of the best types of technologies to really support real-time applications. Okay, so what you're going to see a lot of in the industry is a lot of session-based failover. So if they're on a real-time application such as a Zoom conference like we are on right now, or on a VoIP conversation, packet level failover is going to be able to support that real-time technology in the case of an outage or fail. Unlike some others where you might get a failover, but you're going to have to drop whatever real-time application that you're in the middle of. So us as a provider that has a lot of customers that utilize these type of tools, that was important for us to be able to bake that kind of value proposition into our product. We couldn't do that without the technology that VeloCloud provides and the DMPO technology that you're going to see in a little bit. A lot of work from home applications also is going to be adopting that as time goes on, right? So that's an important thing. And as you can see, lastly, in the slide that we're looking at here, 2,500 plus application profiles. So of course you can map applications doing in other ways, but the sort of the layer 7 awareness that the orchestrator provides to really easily target specific applications, and these application profiles are growing each and every day, makes it easier for us to identify specific applications that are in customers' network and customers' pocket, if you will, but also if there's unique applications that are out there that customers might use that might be proprietary, we have the flexibility to be able to map those type of application types and prioritize traffic for these things that may not be a very common use case. So it's a great combination of ease and flexibility in terms of prioritizing traffic and getting customers what they need. So those are all the things that really helped us drive our decisions. We've been, like I said, a proud partner, and we're excited about what the future holds for this technology. So that's it from me. I'm going to hand it over to my colleague, Derek Donian. He's going to talk about a couple of use cases for some of our customers.
Thank you, Stephen. Hi, I'm Derek Donian, the Director of Sales Engineering at NetFortris. I'd like to share how SD-WAN can benefit a variety of business types with a few of our customer case examples. With the first example that I'd like to review here, we have Tronix, a global mining operation with a wide variety of circuit types, was able to connect remote locations and quickly onboard new acquisitions. This enabled the company to quickly realize global communications amongst all of their sites that were spread in very remote locations, being that they're a mining company. With aggregation and stabilization of the variety of smaller bandwidth circuits that were available to them, and also the ability to see the breakdown of traffic that rides across the network. The improved management oversight has enabled Tronix to keep costs low by only adding bandwidth when it's absolutely needed. In addition, they were also able to have a third-party MPLS network that needed to remain for specific reasons. This was able to be integrated to participate as an alternate path in the case the SD-WAN network at a given site becomes unavailable. Traffic was then able to be backhauled through their MPLS network and reach the rest of their sites as well. And now we're going to take a look at our second example, Badger Daylighting Services. They're a US and Canadian industrial services company and has utilized SD-WAN for a quarter of their most critical sites, along with a hybrid legacy IPsec network for the other 75% of their sites. This enabled Badger to realize a massive network migration from physical data center assets to a more dynamic cloud services environment. Site circuit stability was also of prime importance to them due to their remote, hard-to-reach locations. In some of these locations, bandwidth can be hard to come by, at least in large capacities, and also of quality circuit types. With utilization of some of the features of the SD-WAN services, they're able to smooth out those problematic circuits and enable those remote locations to be able to conduct business nearly 100% of the time. And by replacing their older MPLS network and self-managed star mesh VPNs, they were able to improve the bandwidth, the network efficiency, and the manageability of their overall network by their on-staff IT team. And for our third example, I'd like to review Cash Store by Cottonwood Financial. They've utilized a variety of bandwidth types and qualities in metro and rural United States, mostly in the southern areas of the United States, to ensure their financial customer service locations are always able to do business. Whenever sites are down, they always, of course, lose quite a bit of business as people are standing in their lobby trying to process their transactions on the spot. So with the additional security provided by the SD-WAN network in the form of PCI compliance, has also helped them to reduce their personal scope within the PCI realm and ensure that data is in good, trusted hands from point A to point B. Cottonwood has also begun a migration from physical data center assets to cloud assets, with SD-WAN providing a much more efficient way to access those cloud environments, and then also a secure method of access for obvious reasons, being a financial institution. With over 300 sites, the granular management oversight was also a critical need for their IT team. And for the last example, we'll take a look at a different sort of customer case altogether. Southwest Key Programs, an educational and housing institution and facility, utilizes their network not only for business purposes, but also for the needs of their residents as well. Services such as Xbox Live, PlayStation Network, and Steam place a lot of load on the network after hours, with educational streaming and business cloud utilization during typical business hours. The ability to balance the variety of real-time traffic across their variety of fiber and broadband circuits was an absolute must in their decision-making process. Southwest Key also struggled with understanding how their bandwidth was able to be utilized, regularly throwing more money at an ambiguous issue. With the granular reporting that VeloCloud SD-WAN has provided, it helps them to keep their bandwidth costs low by understanding exactly what is occurring on their network, what traffic is flowing across that network, and how exactly it's being utilized at all times, day and night. And for the last segment, I'm going to hand it over to David Pluis from TGO to review more of the in-depth technical aspect of our SD-WAN services.
Hi. So, thank you. I'm David Pluis. I'm a solution architect here at TGO. And there we go. So, our solution here is based on VMware's VeloCloud technology. It delivers a cloud-ready network providing direct path to public and enterprise clouds. It secures the SD-WAN overlay tunnels edge to edge or edge to cloud, and enables access to traditional enterprise data centers and cloud applications like software as a service and infrastructure as a service. The key three elements of this are the network edge, gateways, and orchestrators. VeloCloud edges give you flexibility when deploying. We can give you purpose-built hardware or virtual edge devices with designs for both the branch, data center, and the cloud. The orchestrator is a cloud-based management system that provides business policy abstraction and automation, enables fast deployment and zero-touch operations. And the gateways provide optimized cloud on-ramps for software as a service and infrastructure as a service for they're fully managed and operated by TGO. The VeloCloud Orchestrator gives you in-the-cloud management and control of your network. It provides a consolidated dashboard for complete lifecycle management, including SLA measurements, remote diagnostics, link quality views, and application analytics, as well as bandwidth utilization, network-wide business policy automation, and for traffic, including your voice, video, along with granular application and security policies. Combined with the zero-touch capability, can dramatically accelerate and simplify the provisioning of new sites. The SD-WAN, with my limited time in front of you, I'd like to highlight one of our key technical features of our SD-WAN product, the VeloCloud's unique dynamic multipath optimization technology. DMPO delivers a resilient overlay network that, by monitoring the real-time performance of WAN links, allows it to autocorrect for packet loss, latency, and jitter, and to automatically steer around link failures. Although SD-WAN solutions mostly rely on internet links to build the overlay network, VeloCloud DMPO technology delivers traffic control and QoS mechanisms that enables applications to select the path with the best performance. VeloCloud combines all of these measurements into a single metric called quality of experience. There we go. At TGO, we have an extensive SD-WAN demonstration that we'd be very happy to run for you. But normally this demonstration can take anywhere from 30 minutes to over an hour. Our SD-WAN demonstration runs on a small SD-WAN network that we have deployed in our data centers. These data centers in Cologne and Thornhill have been set up as branch offices. And these, with a TGO internet DIA circuit and a broadband connection. In Mississauga, we're simulating a hub site. At the hub node, we have a server running several applications, including an ERP, a file server, and a packet generator. We also have 4 gateways set up that will provide access to software as a service providers. And finally, we have the orchestrator running in the cloud. Well, I cannot run the full SD-WAN demonstration at this time. I'm going to play a short video that will demonstrate a couple of the key features of the orchestrator and how DMPO can ensure quality connections with even the most misbehaving links. The first part of this video, I'm using a account that has a standard customer view and privileges. so that I can provide you with a general overview of the dashboards that are available. As you may notice, this customer profile has access to the monitoring functionalities provided by the SD-WAN Orchestrator platform. This section provides our customers with useful dashboards that allow them to have full visibility of their SD-WAN. We're going to start with the network overview here. This dashboard gives you a high-level overview of the activated edges, the number of links, and their status. This dashboard will allow you to quickly see if an edge or link is down or in a degraded state. The edges dashboard provides you with a geographic map and a summary of the edges that are part of your SD-WAN solution. As well, you have an option to customize the table by adding or removing columns. There we go. You can jump to a specific, in this case, we're going to Kelowna. For this, will provide you with location-specific information. The VeloCloud's Quality of Experience tab provides the VQS or VeloCloud quality score for different applications. It also provides information on the latency, jitter, and packet loss. The QoE tab provides you information on the performance of the network. Transport tab provides throughput over time, and you can monitor, allows you to monitor the in real time as well as the performance of the links. Applications shows you the traffic generated by specific applications, as well as the sources show you the usage of specific IPs. Destination shows you the destinations where your traffic is going to. System shows you specific edge KPIs, related to the health of your specific device. I'm switching to my admin privileged account here. This will allow me to demonstrate a business policy framework to meet service assurance, security, and corporate governance. We'll set up a business policy rule to optimize the SD-WAN network for voice. We do this by clicking on the configure in the orchestrator and then going to edges. From there, we're going to click on Kelowna to configure the Kelowna edge device. What we're doing is we're setting up a business policy specific to voice. Currently, there are no edge overrides. Everything at this point is set to the default global settings for all locations. Clicking on the new rule button, we will set up a new rule for, again, specifically for the voice application. The any-to-any for the sources, and we'll define the application. There are over 3,500 applications that VeloCloud automatically recognizes. We're going to leave it for both audio and video for Skype. And leave the priority at high. Multipath allows the DMPO algorithm to automatically calculate and ensure quality service. While the WAN link, we're going to prefer the TGO internet connection. If we leave it set to mandatory, it'll route all traffic specifically to that link, whether it is up or down. Preferred will allow the DMPO algorithm to send traffic to the TGO link if it's up, or reroute it to the broadband connection if there is an issue. Once we have our rule set up, we click on the Save Changes buttons to activate it. And then we're going to go and monitor the connection. The Kelowna location here, we'll start with live monitoring. Now, we're going to initiate a Skype call. You have a Windows 10 virtual server set up within the Kelowna location. or workstation, we initiate a Skype call to that Windows 10 application. Once we go back, and we can see here, the blue is the UDP packets generated by Skype, and they're all going over the preferred TerraGo's link. Now we'll simulate a network failure of that preferred link by generating 100% packet loss via a WAN emulator. You can see instantaneously the traffic has, the VeloCloud instantaneously moved the traffic for Skype from the TerraGo link to the broadband connection. Now we're going to introduce a bit of latency or packet loss issues on the broadband connection in one direction. And the call continues. Again, the error correction is kicking in to ensure that the quality of the voice call would be uninterrupted and the people using and communicating would not be aware of any particular network issues. Adding additional packet loss in the other direction on the broadband link. And you'll notice that there is a bit of an uptick in the received bandwidth there as it attempts to additional error correction to, to ensure that the quality of the voice continues. The call is still connected. Looking at the QoE tab, we can see that it's recognizing that the primary link is down, and there is red on the SHA link, broadband link, with significant critical packet loss. But due to the error correction and of the algorithm, communication for that voice call is still rated as good. What we're going to do now is just remove the network failure status. We've managed to restore service on both links. And as soon as the service is restored on the primary link, the traffic was restored to that primary TerraGo network. So what we're demonstrating here is that this is the power of that DMPO technology and the quality of experience to allow businesses to continue to operate even when they have a network failure and significant packet loss. So, and with that, that's the finish of my short little demo video, and I hand it back.
Great, thank you, David. So as you're aware, we have entered the attendees, those who were within the first 50 registrants for today's presentation, in a draw to win a Netflix gift card. So congratulations. Really so I'll be reaching out to you shortly after this webinar to provide you the prize. So again, congratulations. So with that, that concludes the formal presentation for today. So I think we can switch over to the Q&A and address any questions that have come through. So I know we've received a couple questions throughout the presentation, but if you have any further inquiries top of mind, feel free to add them into the Q&A at the bottom and we'll address them. So it looks like there's one question here. How does SD-WAN maintain traffic security over internet circuits, which are inherently non-secure? So if the NetFortris or TerraGo team want to address that, please go ahead.
All right, so the Yes, internet circuits are viewed as inherently unsecure, but we are using the NetFortris, the VeloCloud solution does use VPN tunnels, the latest levels of encryption and highest levels of encryption to ensure that the traffic is secured end to end. I don't know if NetFortris wants to add anything to that.
Sure. This is Derek again. The encryption methods that are used are SHA-256 and AES-256, so up to today's standard. And like David was saying, it's based on IPsec, so it's inherently a secure protocol that everyone is still very familiar with and still very secure in the grand scheme of things. So along with that and the newer encryption methods for IPsec, SD-WAN employs those. And also the network that our gateways reside within has been subject to yearly audit for PCI compliance and still maintains that. So the gateways fit within the PCI scope, that fits in within our PCI scope, so it takes that burden off of the customer. And the orchestrator itself that actually kind of orchestrates all of the edges and gateways is outside of PCI scope because no data lives with it, no data passes through it. That would be payment card traffic or any sort of other financial information.
Great, thank you. So it looks like there's another question here. Is there any hardware required on each computer or at each firewall location?
So,
And
sorry, go for it.
This is Derek. Yes, there's hardware that is required at each of the endpoint locations. That is a VeloCloud Edge device that it gets placed out there, now owned by VMware. That is essentially the device that terminates those circuits and then interconnects to the rest of the network. There's also the ability to do virtual implementations as well on virtual machines that might be in a cloud or in a data center somewhere, rather than an actual physical device.
Great. And is there recommended bandwidth for voice and data?
Generally, when I run a calculation on for voice, as a rule of thumb, if you're using, say, an uncompressed voice call, you run a budget around 100K per call path, I would say. Yes, voice calls can be compressed down further depending on the protocol, but there's always going to be potential for uncompressed voice. For data, it really boils, it's more of an in-depth conversation. It varies from customer to customer as to how many end users there are at each location and how many what is the applications are running, who are you, as the data center in-house or in the cloud. But we can work with individual customers to calculate the best bandwidth required. But once that's done, we can find a way to provide a solution that will fit their needs.
Great, thank you. Okay, looks like there are a couple more here. So is Cisco UCS supported?
I suppose, in what form or fashion? I'll answer that. Cisco Unified Communications Suite, as far as from a voice perspective, is able to be managed over the SD-WAN.
One more here. Is TGO's SD-WAN compatible with Canadian data residency requirements?
I'll take that one, Katie. Sorry, David Whale here. So I've done some of this with our legal department. So first of all, Canada doesn't have an overall data residency law. There are some provinces that have set out some restrictions on things. So for instance, Ontario has restrictions around data residency regarding healthcare data. And Nova Scotia and it's British Columbia have some restrictions based around public sector data. And this is a really good question because TGO's SD-WAN platform is, of course, a cloud-based system. And as a cloud-based system, it has really two components. There's the orchestrator, So the orchestrators, there's actually two of them. They're geodiverse, they're cloud-based systems, and they're located in the United States. Both of the orchestrators, they're obviously redundant. They contain network configuration and network policies specific to the operations of the customer's network. And the SD-WAN gateways, again, those are geodiverse cloud-based systems as well. They manage all the real-time operational information about the customer's network. And the SD-WAN gateways are, for Canadian sites, they're all located in Canada. Of course, if you have a site that's international or in the US, we would use gateways that are closer to that site. But because the SD-WAN platform only manages the configuration and operation of the customer's SD-WAN network, it doesn't actually analyze, store, or handle customer data in the sense that anything's going back to the platform. Obviously, it's a network, so it's transporting data. The consensus of the legal teams when we looked at this is the SD-WAN platform doesn't contravene any customer data residency or data sovereignty requirements. And keeping in mind that data sovereignty means about where the ownership resides, and data residency refers to where the actual data resides when it's being stored. A bit long-winded, but I hope that answers the question.
Thanks, David. So it looks like a couple more are rolling in here, which I think we have time for. So we'll do 3 more. 1, are you able to create a static environment with dynamic IPs being used?
So yeah, so I'm assuming you're talking about the WAN connections, like be either broadband or internet connections into the devices. So yes, you can use dynamic IPs to connect into the SD-WAN edges that we're deploying. That can be either, we can use static, we can use dynamic, either can be used. In that, the way that the SD-WAN environment is set up is that those devices because they're controlled by the orchestrator, provide a stable and static environment for the customer's businesses to continue to operate, even if it is dynamically assigned on the WAN side.
Great, thanks. And are there VM application hosting capabilities on the SD-WAN appliances?
I'll take that one. Yes, I mean, there's a wide variety of VMware applications, but I suppose it depends on what types of applications are wanting to be hosted. It's not really so much hosted on the device. It would be more hosted, the SD-WAN edge image would be hosted within a VMware application. I think that's a better way to put it. Great. I hope that answers the question.
Thank you. And then we can finish off with one here. How secure is the remote endpoint client or edge device? How secure is that client against hacking or against unauthorized remote configuration?
So the security in the actual environment itself is not limited just running tunnels over the internet. There's also security between the orchestrator, controller, and the edge devices, and that security ensures that the edge devices are never communicating. Their internal control traffic is never unencrypted. It's never going over a channel or connection that is open or available for anyone to see how that is working. So, by having that centralized management of the orchestrator, which is secured and controlled, managing your edge devices, those edge devices are not going to be open for remote hacking or remote controlling, because that they will not respond to those requests.
Thank you. So it looks like I've missed one. Would you use SD-WAN solution, the SD-WAN solution within a WAN MPLS network, since MPLS should be encrypted, and what would be the advantage, if any?
So, yeah, you can set up a hybrid environment. What's being described there is a MPLS, and some sites on MPLS, some sites on SD-WAN. Sometimes you can do both. The VeloCloud can use private connections on the edge devices. The connections to it don't have to be entirely public. You can have some sites on an MPLS and then a bridge or a gateway to the SD-WAN environment for, such as where you have, maybe the data center in a head office on, the major core sites on a private MPLS, and then the edge branches are on SD-WAN. So there's various ways of incorporating MPLS in SD-WAN into a hybrid environment. The advantage is, if you already have an MPLS environment in place and you don't want to remove that because it's working for you, but the advantage is that MPLS gets very expensive going to the edge for branch locations. So a common solution is you have the small branches with, say, broadband connections, and all those small branches are going back to the data center to combine and connect into the MPLS for whatever services may be required. So then you can have that sort of setup. And all through it all, yes, everything would be encrypted and protected.
Thank you.
And one other thing I want to add there too, before we move past that question, is SD-WAN also retains the ability to affix DSCP tagging to the traffic, and also retain the tags inner and outer for the traffic that passes from MPLS into SD-WAN, or vice versa, SD-WAN back into MPLS. So in utilizing traffic flow from either direction, you're going to keep the pieces of the QoS that are also usually valuable to an MPLS network. So you can kind of manage it in both ways.
Great, thanks for clarifying that. So we can finish up with one last question. What model of SD-WAN appliances are recommended?
I can talk to this.
So go ahead, Stephen.
We have several models available, and really it comes down to a couple of different components. The amount of traffic that you're routing through the box, and the kind of use cases that you're running into, right? So we have boxes that could be the size of a small book that could handle perhaps a couple hundred megs of traffic, all the way up into multi-gig, 1U rack units that could handle a headquarters or a data center location. And these boxes are going to A, handle that additional amount of traffic, and B, handle different amounts of flows that come into those boxes. And that really just depends on the kind of topology that you have set up, whether you have a kind of a hub and spoke type network, point to point, or you're routing everything back to the gateway. So for a lot of headquarters locations, you might have perhaps a relatively small amount of bandwidth, but you're going to have a lot of the traffic flowing in and out of that headquarter location. So to handle those different types of routes, you're going to want to have a box that can max out at that amount. And so the good thing about the solution is, as I mentioned earlier, we have several different purpose-built units that are meant for this solution. So the solution architects and sales engineers can really scope out, based on your use case, what the best box or boxes that's going to work well for that type of environment. And that's what's great about this solution.
Great, thank you. So that wraps up the Q&A. I also just wanted to reinstate, as I think we got muted there when we were announcing the winners. Congratulations to Zoran Popovic for the winner of Netflix gift card. So we really appreciate your participation. I'll follow up with you after this webinar, and we can get you your prize. So congratulations again. And I think that wraps up the whole presentation. So if you have any further questions or inquiries, please feel free to reach out to TGO or NetFortris team. Thank you very much for participating today. And we will follow up with you shortly, providing some more details on the materials you saw today, as well as providing you the webinar recording. So thank you very much, and enjoy the rest of your day.